And next, we've got Janis Griffin, who's also an Oracle Ace, and she works for Quest. So you got to hear from Clay earlier from Quest. This is his colleague Janis, another great presenter and supporter of user groups like NYOUG. So we're super glad to have her. And after that, keep looking for that email from Katie. I just touched base with her and she is still working on getting them uploaded. She says it's just going a little slower than normal. So be patient. I promise we'll have them to you. And then sign up for tomorrow's session if you haven't already. All right, Janis, I think we're good to go. It's all yours.
Okay, great. Thanks, Monica. I too want to thank you all for joining me here today. This is exciting to be always invited by New York User Group, and thank you, Viscosity, for taking some very good topics and getting them over to everyone. My name, as Monica said, is Janis Griffin. I've been a long time DBA. I started out with Oracle 3, if you will. And my presentation, if you've ever heard me speak before, is going to be on my top 5 Oracle performance tuning tips, the need for speed. So just a little bit about myself. Like I said, I've been a long time DBA. I actually was an Oracle Ace director until COVID hit. And then of course I couldn't basically, keep that up. So let me share my screen and we'll get started here. Okay. There we go. So now I'm an Oracle Ace and hopefully you all can see my screen. And just a little bit about myself. Like I said, longtime DBA, started with Oracle version 3, worked with many other databases throughout my career. I've actually came to Quest going on 4 years now, and there I work with our customers, our prospective customers, looking at their databases and giving them some ideas of how to monitor it, what to do with bottlenecks, and oftentimes we'll run into a query and they'll go, well, how do I tune it? So this presentation is basically on my 5 tips. So the agenda is we're going to talk about the challenges of tuning, and then we're going to jump right in. And I know we're late, so I'm going to kind of hurry through these initial slides, just so we can maybe recoup some time. But let's face it, SQL tuning can be hard. I mean, Oracle has a lot of knobs and a lot of features to actually think about when you're trying to tune SQL. And a lot of times it's even hard, even with any type of database, to even figure out who should tune. Is it the DBA, the developer? I mean, which SQL to tune? I used to ask when I did this in person. I asked for a raise of hands of, have you ever tuned something and no one notices? Well, chances are, if you find that happening a lot, you may not be working on the right things. So tuning requires a lot of expertise in many areas. You need to know the different data access paths. How is the optimizer going to pull that data off disk? Is it the best way? Did the optimizer make changes? I know the optimizer is getting more and more intelligent, but still it can make some errors at times. Also, what about the join methods? Is it choosing the right join method? And also, you need to kind of know how to write good SQL. I also think it's important, the business reason for that SQL. Who's running it? Who's it for? What are they using it for? How often is it running? Years ago, I mean, the easiest tuning, a gig, if you will, was shutting down some accounting reports because accounting clerk had inherited this job to always run these reports, and they were horrible. They're running, some of them were running, days at a time to complete at the end of the month. And, no one was using them. She was just instructed to file them in a filing cabinet. When we looked around, they were obsolete. So that was the easiest tuning effort I ever did, was just shut that off. Tuning takes time, and then there's no cookie cutter approach. And then finally, a lot of people think they can throw hardware at it, but if you've got poorly running SQLs, it's just going to eat resource. It may buy you some time, but it's an expensive solution because you're going to see that SQL again, especially as workload changes and data grows. So let's just jump right in and start with my tips. So tip number 1 is monitor wait time. And wait time is nothing new. A lot of times we call it response time, but when you think about it, if you've got a revenue generating application and the majority of it is spent in the database, then you're wasting time, because there's, especially inefficient queries, maybe waiting on things, maybe waiting on resources. And so, like a lot of database types, Oracle was one of the first to actually instrument itself with wait events. And basically what it is, it watches a SQL statement as it processes through the database and records off the resource it's either using up or waiting it on. And so if you can capture that, which AWR does, you can actually get some very good information about what resources it's waiting on. And not only that, the wait events give you clues on how to tune it. So you can quickly rank which SQLs to focus on, especially, like I said, if you've got that revenue generating application where the bottleneck is the database, and you could actually speed up, the bottom line. It's not rocket science to actually do wait event type collections. Basically, these tables will get you most of the information, these virtual views. And these views basically are in-memory persisted. They're not, associated with AWR. I mean, they're not proprietary. It comes with every database, even standard. So you could write your own monitoring tool and get the same information. Basically, all you have to do is look in $V session, grab the serial number, the SID. You can grab all this information about the session that's running, as well as you can get the SQL that it's running, and this P1, P2, and P3, and the text is actually what it's waiting on. It'll give you more information about the wait event. And then you can also see if it's, blocking as well. And you get the state of it, of whether it's waiting or waited. And you can join that into $SQL, which will give you the full SQL text. It'll give you some idea of whether it's bind sensitive, what's supporting it, if it's a SQL profile that's supporting it, a patch, a baseline. You can also see if it's reoptimizable. You can also see if it's been, resolved adaptive plan. So it gives you a lot of great clues on that SQL statement. And then finally, you can join into $SQL plan. We'll give you the cache execution plan. And then, of course, these other views or tables for database objects. You get the object name and the type, as well as you can, with $SQL area, you can get the executions, disk reads, buffer gets. This slide doesn't really have all the columns, but it gives you a lot of execution, statistics that you can see where it's spending its most time as well. And then if you have bind variables, you can actually get a sampling of the the actual bind variables and see. This one is my go-to for looking for implicit conversions. Seeing how good the developers are in maintaining the correct data types when they're actually writing their code. And like I said, it's not rocket science. If you wanted to build your own tool, it's easy enough to do that with those tables I just mentioned. You can actually create your own table. I just created this table I call it WTA data for wait time analysis. And I'm just selecting the SID, the serial number, information about the session, and then look at my decode. I'm actually looking at state, and if it's waiting, I grab the event. Otherwise, I think I consider that it's really on CPU or waiting in the CPU queue. And then you can grab different information about that event depending on what that event is, and then notice my timestamp. Now, I can just run this query, and a lot of monitoring tools, and same way with AWR, will monitor every second, and they'll put this into another table. And then basically you keep monitoring, and what you can get then after you have monitored for a while is you can actually run this query that'll actually summarize the total time a SQL statement is spent in the database, but it'll also break it down to where it spent its time the most. So as you can look here, and I think I did this maybe for a minute or 2 minutes, just pulled every second, just manually. And you can see my bottom query here with a SQL ID that ends in G76. I spent 1 second on CPU, spent 1 second on parallel read, and 25 seconds on a DB file sequential read. Now that, I'm not monitoring for a lot, but it is the one that spent the most time in this time that I was monitoring in my database. And now I have some great clues on where to tune, because DB file sequential read wait event has a lot of options on what you should do to speed that up. Now, if you don't, if you have the proprietary tuning and diagnostic packs, you can actually view $V active session history. You can look at all of this information. You don't have to build yourself a tool. Basically, the data is sampled every second, like I said, holds at least the last hour. How it determines that is if you've got SGA target turned on, it's 2% of that. If not, it'll use 5% of the shared pool. After that, it flushes, I believe, every 10th record. It's kind of a funny way that it flushes its history to this WRH active session history table. It's also known, as a DBA view as DBA HIST active session history, and you can look at it there. Now, this is only available for you to look at if you have Enterprise Edition. It's out there, but you're not supposed to look at it, in standard. But what you can see here is you can run the same query, and I'm looking at a $V active session, and I'm getting my information, my stats from SQL area, and database users. So you can fill in with other views, and you can get the same type of information that this one query here and doing an update, and you can see that it spent, 0.554 seconds, I guess, if you want to read that all out, half a second in the database, mainly waiting on, log file switch completion. That was the most time. It did, have to grab a lock, and then it spent some time on CPU. So again, great clues, to figure out where I should tune. Now this, of course, we're only monitoring for a little bit, but you can, as you monitor over time, you're going to see, things bubble up. And this is a great example of showing this in a graphical view where you can see when you're looking at your total workload, which statement is spending the most time in the database. So nothing new with this, is just putting it into a graphical view. I have my SQL statements here, and this very top one, I'm looking at workload only, but this very top SQL statement actually bubbled up to the top as being my main SQL statement, spending the most time in the database. And oh, by the way, it spent 100% of its time on CPU. Now, this information is becoming more and more important as as the entrance of cloud databases, because you're charged by CPU. So as you consider, adopting cloud technologies and moving to the cloud, you have to really kind of look at your existing on-prem databases and make sure that they're not inefficient in using CPU. If they are, this is something that you want to fix before you go to the cloud, because it's going to be quite costly if you don't. Another thing about wait time analysis is it actually gives you great baseline metrics. And as you can see here at the bottom of my slide here, I see how active time, the active time I'm looking at, this is looking at the last hour of data. So within this last hour, it spent this much time in the database. It actually, gave me buffer gets of 116 million in some. You can see the executions, and let's see, this slide is in the actual controls are in the way, but you can actually see the I believe that's the row executions here. So this is a good baseline metrics if you're going to tune. And like I said, I like to gather the baseline metrics. Years ago, when I first started tuning, I almost drove myself nuts because I didn't know when to stop. So it's good to grab some baselines at the beginning, and then figure out before you start tuning what's acceptable. Because like I said, you can drive yourself to the nth degree of trying to tune it, but you really want to try to get that 80-20 rule where you've gotten it good enough and then move on. Because I'll guarantee if it's a popular SQL statement, as workload changes and the data grows, you'll probably see it again. But so figure out what is acceptable, when to stop tuning. You'll do yourself a favor. But I usually get the number of buffer gets. You think about queries in general. You may have to do a physical read, but you might not. So, but at least every query has to do at least one buffer get. So if you use that as a metric to tune and you can reduce that metric, just think about it. You're actually saving and speeding up that query. So I usually collect my buffer gets. I also collect the weight information, and like I said, weight events give you great ways to tune. There's a lot of them out there. You may see locking, blocking. You may see, IO problems, latch contention. It might be multiple issues as well. And a lot of times what I'll do is I'll rank my weights, for the query, and I'll start on the one it's waiting on the most. So here we've got one, and this one it's waiting on log buffer space. And then I kind of look through the rest of it. And I also got, this top 3 are configuration weights. So maybe there's something I can change in my configuration that might help that. And so there's great clues on that. And once you start tuning one, some of the others might, disappear as well, or you may have to tune, multiple weight events. Other benefits of wait time analysis is because you're pulling that data, you can see changes over time. And so this is a representation of the workload. You can see the workload here was kind of small, and all of a sudden it was, under a second. All of a sudden it jumped up to almost, kind of spiky at 3 seconds here. Well, then you can see these different, dots are actually changes in the database. And so you can see, this was an actual execution plan change. We can see it actually changed. It went from using an index to a table, accessing a table, full table access. So, and you can see it actually, after that change, kind of increased up to 2 seconds each execution. So changes like that are great to catch, and it's great to see. So you're not left scratching your head going, well, why did it change? I mean, I always hated that when when people would come to my office as a DBA and they would say, what did you do? It was running fine just yesterday, but you changed something because it's not running fine today. So that's wait time analysis. That's my first tip. My second tip is to review the execution plan. And Oracle gives you lots of ways to look at execution plans. You can do an explain plan. They just remember that it's an estimated plan only. It can be wrong for many reasons. Basically, it's Oracle's best guess at what it's going to do, because it's blind to the bind variables. So it doesn't know data types of what you're passing into bind variables. It just assumes you've got the column data type. You can actually run explain plan 4 and get the statement, or you can use DBMS Xplan display. I like to use set auto trace to explain or exp only, just because I don't want to see all the rows coming back. That's my shortcut if I'm using explain plan. You can also use tracing. Tracing works for all sorts of information. I don't use it much because it gives too much information a lot of times. And it's hard if you're specifically looking for a problem because it's giving all the information, and it's hard to narrow it down that way. And you don't want to turn on tracing and leave it on, because it is another process out there working and taking up resource. I use $SQL plan and get the cache plan, and see what that's doing. What's nice about that is I can go to production and see, okay, this SQL is running really bad. Let me see the execution plan that's already cached and what it's running. And then I can see and determine, is it the plan? What else is going on with this SQL statement? You can also get historical plans, AWR, Quest Foglight. These will show plan changes over time, and they're useful because plans don't always change for the better. They can regress over time. Oracle, in recent, versions have tried to adapt, and they've tried to, adapt the plans on the fly to help that, and to some success, it's better, but they still can regress for, whatever reasons. Right now, I want to just kind of go through the steps of what an execution plan is and how it gets created, because this is something that, even if you're a seasoned DBA, oftentimes it's nice just to, go refresh yourself on what, an execution plan is and how it's created. So once a new SQL statement gets, through the parser, and it's checked for syntax and all that good stuff, what Oracle tries to do is it tries to transform that query. It actually sends it for rewrites to try to make it more efficient. And I believe, over here on the right-hand side, I think this came from 19Cs, but this is all the things it looks at when it's trying to transform that query. It tries to, looks at the joins, it looks at, star transformation, if it's a star schema, it tries, looks at materialized views, view merging, all of this. It kind of runs through, and it runs through for, a period of time until, it comes up with one that it thinks is efficient, and then it'll send that to an estimator. Now, what the estimator does, it looks at all the selectivity, the cardinality, the cost from the data dictionary, the schema, and the statistics, and it sends the transform query and the estimates to the plan generator. And what the plan generator will do, and it'll do it a number of times, it'll try to create multiple plans using different types of access paths and join methods, and it'll try to figure out those plans, and then it eventually choose the plan with the lowest cost, and then it'll send that default plan to the row generator to create the execution plan. Now, depending on what version you have, there's different features that will control how it does this. And so you always want to look at optimizer features enabled to make sure you know which version and which features are being applied to the optimizer. And I'll talk about that a little bit later. So once the row generator, comes up with these steps, basically, you can kind of look at the execution plan. And this isn't a comprehensive list of anything. It's just kind of giving you the idea of what you can see in the execution plan. So you can see the order in which the tables are referenced. If you've got a multi-table query, you can actually see the data access paths that it's chosen. Now, index, table access, or a view, these are, like I said, this is not a comprehensive list. These are some of the common ones it will decide on using. You can look at the join methods if it has multiple tables. Hash joins, merge joins, nested loops are popular ones. There's other ones, the Cartesian join is one, but you'll have to come up with a join method. And then, of course, there's data manipulations within the execution plan. If you're concatenating things, if you're doing counts, filtering, any aggregation, you're going to see that in the plan. What became new in 12C was statistic collectors. When they came out with 12C, they came out what they called adaptable plans and an adaptable optimizer, really, because what happened is they had a number of things that the adaptable optimizer could do. And one is let's sniff a little bit of the data and let's compare it with my default statistics to see if it's correct. And if it isn't correct, then let's change the join method from either nested loops to hash joins or hash joins to nested loops on the fly in the very first execution to try to stop that regression that you would see a lot of times. Ran good for one and then all of a sudden went bad because it changed the join method, or maybe it never got the join method right the first time and then it actually got better. So they were trying to get it more stable. Okay, so after you get the execution plan, we understand what that is, then how I examine an execution plan is I look for expensive operators. And what I mean by that, I'll look at the cost, not that the actual cost matters, but I'll compare all the steps and I'll find the one with the highest cost and I'll review that. I also look at the row counts at each step, to see, is that really warranted? Knowing that, maybe my result set is really small and I'm reading millions of, records. Is that, is that possibly a wrong thing? I look for full table scans and index scans. Not that they're always bad, but again, you gotta consider the query and what it's returning to the end user. If it's selecting all data, let's say you have two tables and they're both 1 million rows each, and they join all that 1 million rows just to return 1 or 2 rows to the to the end user, that's a waste of time to me, and I would look to try to reduce that. Also, looking at the predicate information, understand how the bind variables are being interpreted. Review the data types. Implicit conversions, I feel, kind of get overlooked, and they shouldn't, because implicit conversions can really slow down a query. And not only that, it can eat up high CPU cycles because it's having to go behind the scenes and implicitly convert to a different data type. You can see, when I have CPU, high usage CPU queries, I'm on the lookout for implicit queries or implicit conversions and also high buffer hits. Because if it's reading too much data, it's going to not only be thrashing memory, but it takes CPU power to actually, go through that memory. Also review the join methods. Nested loops, they're good for large table, small table, kind of a master detail type of lookup joins. Hash joins are good for large to large table joins. So if I have, like, I have a case study on, a billing system, and it's really a large table and a lookup table, and it'll want to do a hash join, and that's not a good choice. So the adaptive plan, like I said, may catch that, but it's nice to know the inside workings of it just in case it doesn't. One thing about execution plans, especially since version 12, but it's been growing in the earlier versions too, is the notes section, because it's telling you how that plan or how that query is being supported, with all the optimizer features that are now available. So here's just an example. I chose really simple, like we always have imp and dep. But I'm just looking for employee information with these two tables, passing in a bind variable for department number, and then put my join here for department number on imp and dep. And you can see I'm grabbing it out of cache. So I'm looking at DBM Xplan display cursor, passing in the SQL ID and the child number. Child number is important because there could be different versions out there. But when you do that and you display it, you're going to see, the execution plan. And typically what you do is you're looking at the most indented first. So it actually went and looked at a department in using this unique scan, got one record, and then it did nested loops and looking into imp table. And then down at the bottom, you can see my filtering, predicate information. And I wish I could, let me see for a minute if I can move that, because I've got something in my screen. I know you can't see it, but it obscures my view. So you can see this is actually doing an implicit conversion here. I don't think I wrote to number here. I just said equal to P1. So I am passing, it looks like a varchar as opposed to a number there. Now that is an example of an implicit conversion. Now, of course, behind the scenes, it has to go change that. Doesn't do much impact, except it uses more CPU in this case. But what you've got to be careful with is that it doesn't put an implicit conversion on the column name, especially if that column is indexed, because it'll turn off the index. Now, there's ways you can fix that, but that's just sloppy coding, in my opinion. Okay, it's also important to know, especially in these later releases with Oracle, know what the optimizer knows if you're going to go about tuning. Because, there's so many options you can choose from. So this is just an example of, setting, different versions of Oracle. I've got a 12.2 here, and these are all the optimizer features that are turned on by default. So you can see I have, adaptive plans turned on, and they're true. Out of 12.2, they actually turned off adaptive statistics. So if you want that on, you have to turn it on. And then, a lot of these others, baselines, they're not capturing it by default, but they will use them if they see them. Also, another one here I always check is invisible indexes. Is that turned to true? Because it might, kind of confuse some things, and you'll wonder why isn't it using this index, and or why, what's going on here? So, or why is it using this index? So you have to kind of get acquainted with all of these optimizer features. I found it interesting. I've been working with 21C here lately. Well, yeah, and basically, as you can see here, there's a lot of new features for the optimizer again, as you can see. Sharding came about in, I think, 18C, so they actually have something for the optimizer to help with sharding. I didn't look that up to actually get into it, but also you can ignore now parallel hints. And there's some other things here. One, there's actually optimizer session type. And then there's this whole thing about quarantining, certain SQL plans, if you will. They won't quarantine the actual statement, but it might quarantine the plan so it doesn't use. So, and notice, if it is quarantined, it's set to true by default. Doesn't capture them, but it will use them to set by true. If you don't know what's supporting your optimizer, you're going to probably be scratching your head and trying to figure out, why does this keep running this SQL the way it does? So there's a lot of things to look at before you go tuning, and understand how your database and the optimizer is working in your instance. Okay, and some other things, like I said, you got to look for baselines, profiles, outlines, patches. Look at your statistics gathering. Now you can turn on statistics feedback. There's SQL directives that might be out there because they're trying to make the adaptive optimizer smarter. There's adaptive cursor sharing, and there's adaptive plans. And like I said, the notes here is a good example of how they're becoming more important to know that. This is just an example of baselines. I'm not going to talk about this slide much because the previous speaker actually went into them quite well. But I just wanted to show that if you're using baselines, or if the optimizer is using a baseline, it's going to show it here in the notes field. So you can always check that out. Here's just an example of adaptive plan, and it adapted on the first execution, meaning that it doesn't have to screw up and then the second time fix itself. So how it does that and how you can see that in an execution plan is you can use this plus adaptive format feature. Well, what'll show you what it was going to use and then what it actually did use. So as we can see here, this one happens to be on the sample OE schema. I'm looking at order information, and I'm selecting product name from order items and product, and getting some specific information here. I just put this comment in here just so I could identify it quite quickly. And you can see by putting that plus adaptive, this hyphen here is telling me the optimizer was going to use hash joins, but after it actually buffered up some data and actually reviewed what data it was and the statistics it got, it decided to switch to nested loops. And so it actually said, okay, on the fly, no hash joins, I'm going to use nested loops. In 19C, and this was kind of an exciting feature when I first looked at it, automatic indexing. And at the time when this came out, I was an Oracle ACE director, and we always got to go out and get new information in Oracle Open World at the time. And so this was a big feature that we were all flown out and got to look at. And I was so excited about it because it basically, what they tried to do is put a DBA in the product, if you will. So it has expert index tuning knowledge, and it runs behind the scenes, but it doesn't need a DBA to actually come up with the indexes. And so it is kind of neat. It works incrementally. It's basically a task, uses a session out there that runs out all the time, continuous, and just reviews new SQLs as they come in. And if it thinks of an index, it'll actually create the index invisible. And all the indexes that it creates will be prefaced with a sys_AI, so you can quickly identify them. And then basically it does this whole mantra, it continuously does this, where it captures them, identifies them, it verifies them, it decides whether they're good or not, and then it introduces them to other queries, to the rest of the workload to see if it may regress other ones. and then just continues to monitor, and it changes and evolves over time. What it actually does is it creates these invisible indexes. If it thinks it's warranted to make them visible, it'll make it visible and test them. If it doesn't, it'll just keep them invisible and it'll later remove them. Unfortunately, it's a feature that's only available in Enterprise Edition on engineered systems. So Exadata, probably Exadata only. So you can't really use it if you just have an on-prem Oracle database, but if you have an Enterprise Edition, you can use it in your test and development. Oracle says it won't support it on a production system. It won't support it if you have problems with it, but I don't see a reason why you can't turn it on in testing and development, especially if you're making a new application or you're editing an existing application. A lot of times developers don't have time to look at indexes and in performance. And so if you have this running in the background, you can turn it on with using this hidden parameter. And you have to restart the database in order to get it to use it at the CDB level. But then you can actually get some valuable information while you're developing, or if you have a production database that's very old, but you can replicate the load. You can pull it back to a test or database, run that load, and then see what the optimizer suggested. What the automatic indexing suggests to do. So unfortunately, it's not supported on, so you don't want to use it in production for any means. But I've actually done quite a few tests, and you'll see my examples as we go forward. I actually kind of have tested this too, and it's becoming more and more intelligent. So we've talked about wait time. Tip 1. Tip 2, we got the execution plan. Now what do we do? Well, I always like to gather the object information. It's important to, the table definitions, their sizes, whether they're partitioned or not, the number of rows, make sure it's a table, not a view, or it's not, something, that you don't know. If it is a view, you might have to get more information on that. I also like to examine the columns in the where clause, know the cardinality columns, look for data skew. Look at the histograms, see what, your statistics are saying about those columns. And then I also believe it's important to, review your statistic gathering, because the optimizer can be only as good as the statistics you give it. So if you've got out-of-date statistics, it's going to make some pretty silly, decisions. Even with the adaptive optimizer, it still cannot, always tell, if it's correct. So there might be, some things. So it's prudent to keep your statistics up to date. So there's this tuning script. If you download my slides, I haven't talked to the organizers, but they'll probably be posted somewhere. But there's this real simple script that if you just enter in the table name, it'll spit out all kinds of information to you. So, I went and got my information on employee, and I see there's no indexes on employee. I look at the columns here on employee, and I can see, the number of distincts. I can actually see, the histograms, if there are any on there. And then I can actually go get the histogram that I'm interested in. And so in my where clause, I did have a histogram I did have depno as a where clause in there. And you can see I have a histogram on it because there's data skew. In fact, I don't know if it's like less than 1% in department number 10. The majority of the, records are in department 40. So I also like to look to see when this was last, analyzed, which, this is very out of date. So probably not a good thing. So probably should redo it. I also look at indexes and constraints, and it's important to know what indexes are existing. If they're multi-column indexes, know which order of the columns, and check to make sure all those columns, especially the left leading, is in the where clause. Otherwise, it'll use an index skip scan, which is not as efficient. I also, look to see if there's any constraints. And I went through a period of time, I noticed a lot of developers stopped using constraints because they thought it slowed down performance. But you don't do yourself any favors when you do that, because constraints actually help the optimizer come up with a better plan. And then, always make sure, of course, of implicit conversions, because they can turn off an index, especially if you've, either implicit conversions around an index column, or maybe you put a function around an index column, and that'll turn off an index. You can fix that with Oracle's, has done a lot of things to give us little fixes, because we do silly things. And you can put a function indexes, but it's better not to do that in the first place. And then also check to make sure, that the index isn't invisible, because it may not be using it just because somebody marked it invisible. Again, gathering statistics, is very important. Years ago, we used to do all kinds of different things, especially with very large tables, to gather statistics. And I remember attending a class with Tom Kite years ago, and he says, you really should only set for 2 to 4 parameters, and that's the schema name, the table name, the partition name, and the degree of parallelism. Because in 11G, DBMS stats was written to actually, with auto sample size, to do 100% of the table in less time, and much more accurate than 10% or 25% of the table. So, his suggestion was to avoid using estimate percent, which, I've stuck with in the newer versions, and I really think I would still do that. You can always get what your what settings, the defaults to those settings are for your gathering stats, by using a get prefs function, and you just pass in a name of what you want to see what it's set to. Now, I talked about statistics, fixing statistics. Oracle now tries to do that since 12C. 12C, they actually, for dynamic statistics, they came up with a new level where you can alter the a session to 11, where it lets the optimizer decide whether it wants to automatically dynamic sample or not. I haven't played with that a whole lot, so I can't really tell you whether to do that or not. It seems kind of scary to me. But if you do set on statistics, adaptive statistics, you'll see that it will use statistics feedback, where it will collect and buffer up dynamically some rows and sample them. And then if they're better than the default statistics, it actually stores them in this table, $$ SQL reoptimization hints. And it'll store them as op_estimate hints. So it actually tries to learn as it goes, and which is kind of neat. There's also SQL plan directives. These directives were initially made to answer the problem of people didn't create column group statistics, and column group statistics basically are, really at an expression level. They're not for a specific SQL, a SQL statement. Basically, they're for, an expression that's used a lot. City, state, and zip is one that I think of a lot when I look at that. If you're always using city, state, and zip, why not put a column group statistic on it? That way you give the optimizer more information. It doesn't have to do the math, and it comes out kind of skewed when it does that, especially if they're related. So that's what SQL plan directories tries to do. If there's a missing column group, it'll actually put a directive on it. That was in the first versions of 12. Later versions, a lot of the statistic feedback is also being put in SQL plan directory. So you kind of have to look at that if you turn adaptive statistics on, because it does put it in both places. And so you might want to check that out, especially if you're in 12.2 or in 18 or 19C. Tip number 4 then is find the driving table, and this is kind of old school, but I still have used it in many different database types, and it always seems to work for me. And it's basically looking at each data set as it comes back at each step, and figuring out if that's the right amount of data. And, really I'm looking at the filtering predicates. I want to, filter earlier in the execution plan rather than later, because I wanted the least amount of data first and then build upon it for the select statement. And then, I always compare my buffer gets with my final result set to see, this is just really outrageous. So I try to reduce buffer gets by finding the driving table, if you will. So we're going to work through this little query I've got here. It's an old query. If you've seen this, you've probably seen this query a lot if you've seen me speak before, because it actually came in through a customer. And it was a university that was trying to answer the question, the billing question. They were actually trying to get billing out for people registering for classes. And I kind of changed it somewhat. I made it specifically for tuning, SQL tuning, but they were passing in the class name of all their classes. And so it hadn't changed that. And they were actually looking for a data, a range of dates, but I made it for yesterday, if you will. So the three tables, they were basically selecting first name, last name of student, and the sign up date from the student table. They're doing that on registration on student ID. And they were also joining registration to class on class ID. And they were looking specifically for a certain class. And I was passing in, they were passing in a range of dates, but I was passing, if you will, the date of yesterday, if you will. And so, and I was also, the registration table was historical in nature because they never deleted from it. If a student dropped or canceled, they just marked the flag no, or flag Y if it was canceled. So we were getting only active records, if you will. So wait time, I went and looked at wait time, and we could see what it was waiting on. 118, about 119 million buffer gets. It was, in my little test, it was running pretty efficient at 0.01 seconds. So I couldn't complain about that, but my wait was, cursor pin S wait on X. And you can see that here. It wasn't much because 57% of it was on CPU. So it was CPU intensive for this poor little query that was out there just running. And most of my queries, what I do is I put them in I run usually 5 to 10 sessions and just run them passing different parameters over and over again, and just run a little load with them. So that's how I do that. But so we go ahead and get the execution plan, and you can see right away, I'm doing 2 table accesses of full. I'm doing an index, a unique index lookup in student. But the first thing that I noted is, really, I had a detailed table registration with 2 lookup tables, right? I had, class and student. To me, that should be using nested loops, which it did, but then all of a sudden it changed to a hash join. Why? Why would it do that? And so it did 2 full access, and, and basically, then it used the primary key and student to get the student ID. Cost was 114%. I go down here and I see some conversions, which I had converted and put in there. So I don't see anything outlandish here, but notice it says it's an adaptive plan. I should have printed out the steps that it took out, but it actually must have decided to change from nested loops for this hash join to a hash join in this example. So I go get the relationship diagram, and I can see there are relationships, and we can see the sizes here. Registration about 80,000 records, student 10,000, class 1,000. This is just my data that I contrived, but as you can see, there's a primary key on registration on student ID, class ID, and sign up date. There's a primary key on student and a primary key on class. So, I do have some histograms here that you can see on canceled. It did come up with some with my statistics. So I thought, well, a lot of people use the tuning advisor. So let's go ask the tuning advisor what to do. So I created a task. Whoops, sorry. And created a task and then executed the task. And then reported on the task. And what it said is, we think you should create 2 indexes, one on class name and then class ID, And then we think you should also create index on registration. Oh, by the way, add canceled sign up date, class ID, and student ID. I thought, okay, well, I never know if I should do it or not. And that's why I like the SQL diagramming technique. But I thought, well, let's see what 19C says to do. And so I ran and turned it on. How you set up in automatic indexes, you use that hidden parameter, but then you can actually say, well, I only want you to, put automatic indexes on this schema. And this happens to be the schema where I had my class, application. And then I marked it to implement, to turn it on. And then I just let it do its thing. And basically what it does is it creates these indexes, and it created a fair amount of indexes here. Let's see, 1, 2, 3, I guess these are all different. So, it created 7 indexes. Well, no, customer is not part of these 2. So it actually created 5 indexes for my application. I had other things running out there in the test owner as well, or the schema. But really, the 2 indexes that it made visible was one on class for name and one on registration for class ID and canceled. So I found that interesting. So the thing is, it did come up with the 2 indexes. It did take up those space. Otherwise, it marks it no, they're invisible. So it's not taking any space. They're just out there, metadata only, and then they eventually remove them. But you can see I've got one on class, one on name, one on class ID, and canceled. So what's neat about the automatic indexes, you can see the rationale. You think you may not have control of automatic indexing, but it does very good with some new views, database views out there that you can see. On this one index, it went through and it says, okay, I'm going to create it. It actually created a baseline to support it. It actually, validated whether it improved. If it did improve, it actually made it visible. So this is, the steps it took. And then you can see the verification where it said it improved it. It was the original buffer gets were 17,000 and some. It went down to 325. So it's using buffer gets as well. So let's do the old school. We went to, I'm doing a SQL diagramming. If you've never done it, it's basically drawing a tree, upside down tree of your tables in your query. And basically you take the detail table and you draw links or these arrows out to the lookup tables. And then you figure out the join averages here, how many records are going to come back. And then you figure out the filtering criteria. And that's the one with the underlines. Now, to shortcut this, and you can read this, there's a nice book. It covers many different database types. I've never met Dan Tal, but it does kind of show this whole technique. But the main thing is you just index your join columns. You don't have to figure out this join stuff. This kind of shortcut it. But what I'm saying for the join is for every one student, there's probably about 5 registration rows. For every one class, there's probably about 30. That was how I figured that out within my data set. Then I applied the filters, and there was one on registration where canceled equals no and sign up date equals yesterday, if you will. And 5% of registration was going to be used by that. The other one was in class where I was looking where name equals SQL tuning, and 0.2% was a filter. So only 0.2% of 1,000 was going to be returned by that. So the thought here is to find the driving table and the one with the least amount of data. So I want to drive by class. So it builds, it gets the least amount of data first and then builds on it. So I created an index on class name because that was in my where clause. And you can see it, used it. But I am still doing a full table scan on registration. Why didn't it use registration? Well, because it wasn't left leading. Now, it can't use class ID because it's in the middle of this index. One thing Oracle could do, it decided not to do, was do an index skip scan. It did not use that. It decided just to do a full table scan as well. So I had to figure out, well, I got to put an alternate key on class ID so it can get there and be driven by class. And so what I did was I added that index, and you can see it did reduce the cost. The original cost was, I think, 114. I got it down to 76%, 76%. You can see, or the cost down at 76, sorry. And then you see it's using both of my indexes. And it did adapt. And this time it adapted to all nested loops. It also reduced, quite significantly the buffer gets, the elapsed time, all of that. Okay, let's do what the tuning advisor suggested. And tuning advisor did a pretty good job. We didn't do anything with class. We just, because I'd already added the class name. So I just left that. I didn't put class ID. I thought that was extraneous. It didn't really need that, in my opinion. But I instead, I just put that on there, the class, the index on registration. And you can see it got the cost down to 23%. So again, it did pretty good. Automatic indexing, not so good. It did have those two indexes, but I couldn't get them to use them both. It either used the index on class name, or it used the index on registration. So I was kind of saddened by that, because I thought, and maybe, who knows, if I'd let it run for a couple, days, I did this in a matter of probably 2 days. I let it run, but it never combined them. And so I was kind of saddened by that. I, of course, as a DBA, know the significance of adding a covering index. And I thought, well, you know what? I'm just going to give all the columns that it needs to satisfy the query in my reg alt index. So I gave it class ID, sign up date, and canceled. And the reason why I ordered it this way is because I'm old school, and you always do the most selective column in a multi-column index on the left leading. And so it got it down to 11%. And you can see instead of those 118 million or whatever it was done, I can't remember, but it got it down to 4 million buffer gets. So much better. So did we win? I don't know. I don't know. I kind of sometimes think, I'm arguing with Oracle by using their features, but you can see it. Original cost was 114. The tuning advisor came good. I made him stop there. The school is still out on, why it didn't combine these. I think it could have gotten much better just by me adding that covering index, got it down to the smallest. And you can see the improvement that it did. I was actually recording all this while I was actually doing it. This teal color is really the final result. In fact, it's even, it even ran out. My loop ran it out because it was so efficient at that end that it actually did improve it quite a bunch. So you talked about the 4 steps. We talked about wait time, monitoring wait time, execution, the execution plan, gathering the information about the objects, and finding the driving table. But the one place that I spend most of my time and often do is looking for the stupid, because a lot of times when you're in a hurry, you just you're trying to get it to work and not really looking at being very careful. And so I've got a laundry list of things I look for after I create a SQL statement, or if I'm looking at a SQL statement, just to make sure I'm not doing these, what I call don'ts, or the stupid things, cursor or row by row processing, parallel processing when you don't need it, nested views, using DBA links, abuse of wildcards, using functions around index columns, hard-coded hints, all of these. There's just lists of them. And like I said, if you want to I'm not going to go through each one of these, but if you want to download my slides, they're just kind of a checklist I often look at just to make sure they're not in the query I'm trying to tune. One thing about using hints, and this came from Tom Kite again, but I believe it's true. If you can hint it, don't use a baseline, because a baseline is easier to change. You can change a baseline without having to implement new code. And so this is just an example of doing just that. And it's good if you have third-party code where you can't change, but if you can just change the execution plan. So I had this one query out there, and it was actually doing a merge join Cartesian. I hated it. I didn't want it to happen. And I actually put this little comment so I could identify it. I thought, well, you know what? I'm going to go grab, I'm going to go, change change it. And I gave it a hint, and I, ran it manually and actually got the SQL ID and the plan. And then you can actually change, the baseline by putting it in, by loading it, from the cursor cast. So I did just that. I took this where it was using nested loops and put it in place of the merge join Cartesian. And then I actually disabled the merge join Cartesian so it wouldn't use it. And so that's how you can kind of do that behind the scenes without having to change the code. Real quickly, and I know I started late and I'm probably ending way late now, so I'm going to hurry up with just one more. And I've got 3 case studies, but this one's just another one, a little more meaty. I use HammerDB and I changed it a little bit to be a little more confusing for the optimizer. Again, using wait time. I got the execution plan. I can see I'm doing a skip scan here. I'm doing some full access. I got my metrics. I went and looked at, the indexes, got object information. I noticed stock didn't have an index. And I know HammerDB, their order entry system, it should have had an index. So something failed on the install and I didn't see it. And so, I actually created it. But I also looked because my SQL diagramming said I should be driving it by customer. And as you can see here, and this is me just mapping all of that out and finding the filtering, and that was my best filter. So I first engineered out the stupid, and it was my stupid, and it cut the cost down significantly. In fact, I could have just stopped right there, and I actually did. But I thought instead of stopping, I'll look at what auto indexing would do, just to give it one more chance. So again, it was SOE that was my schema, so I included it. I already had it on implement, and I selected, and you could see it actually put some indexes on customer, on orders, and stock. And so you can see what it did here. It made these that I have in circled here visible, and it put 2 on customer, 1 on customer last. And on the warehouse information with customer ID, and then it put 1 on orders on customer ID and order ID. Well, when I ran the execution plan after it did that, it actually was using both indexes on customer. So it was trying to drive the query by customer, which I was kind of impressed about, that it actually actually took some of that information, which I had SQL diagrammed out, and it figured that out too. Of course, I'd already added my, stupid, changed and fixed my stupid thing. But I was impressed with that. And it did improve performance. It took it down, it was running 0.29 seconds to 0.26 seconds, probably no big whoop, but look at the buffer gets. 10 million versus, almost 2 million, but still a great improvement. Finally, lastly, this is a star schema. If you want to have ever play with a star schema, I would recommend to go to the United States Department of Transportation. You can download every flight for every carrier for every year. I don't know how many years. I did for 2015, but you do it through Excel spreadsheets, and it's a star schema. And I wanted to see what popular airline flights were in the US, what cities were popular to fly to. And of course, there were no indexes because it was an Excel spreadsheet. So, the cost was really high. It's a fact table. So here's my fact table, which was quite large. It was, 6 million. Well, I guess it's, almost 6 million here. So 8% of that was going to be returned. So not a very good filter. Originating city was a best filter to use. So again, I put automatic indexes at it, and look what it went to. It went right to the originating city market ID. So, I think, it actually put 2 indexes on it and used it, look at my cost instead of that. It actually utilized and got it down from, I think, I can't remember, it was quite like 31,000 and some to 4,500. So it was running 10, almost 11 seconds per execution. We got it down to 0.46 seconds. So a much a better view. So in summary, a lot of challenges with query tuning. Top 5 tips, they'll take you a long way. You monitor wait time, look at the execution plan, but most importantly, know that which features are supporting that execution plan. Gather the object information, know when you're collecting statistics and looking at indexes, and also think about considering, SQL diagramming techniques. That's old school, but it's useful to have in your back pocket. Also consider, if you have the tuning diagnostic packs, check out the tuning advisor. It's getting smarter. Also 19C automatic indexes, can't use it if you don't have Exadata, but might consider turning it on in dev and test and just see what it suggests. And then always remember, look at the checklist. Make sure you're not doing something stupid. Okay, with that, and I apologize, I'm not very good at reading questions during, so I'm going to go through some questions. Let's see. Okay, I guess there's not a lot. Let's see. There's one question. Where can I learn how to read explain plan properly? The best, the best is going to the manuals, I would think. I'm not sure what you mean by properly, but to understand all the inner workings of what explain plan is doing, there's a lot of, there's a lot of videos out there. If you go to Oracle's manuals, they'll give you that as well. So with that, and for respect for the next speaker, I want to thank you guys for joining me here today, and have the great rest of your day. Thank you.
Thank you so much, Janis. Actually, you're our last speaker of the day. So
okay, great.
Yeah, so no worries at all. And you know what? So many people stayed on, so I think we all appreciate your time going over the hour for us too. So thank you so much to all of our speakers. Everyone, this was day 3 of 4. So we're back tomorrow again during lunch hours. Hopefully you've really enjoyed these sessions. It's the first, I think, virtual training days New York Oracle User Groups has had. So let us know if you've got any feedback for us. If you're interested in something different next year, let us know. It's always good to hear these things. Also, I did clarify with NYOUG to access these webinars and slides on NYOUG.org. You do need to be a member there. So again, check out their memberships. There's so much in the repository, so you can definitely visit NYOUG.org to see how you can access all that stuff. Otherwise, you can become a free member at AuraPub and see Viscosity's database of webinars and sessions. So I think day 1 and day 2 are about to go out to you all. It'll probably take us till Friday or Monday to get these sessions to you today, but be patient with us. I promise we'll get them to you. And yeah, I hope you guys have a great rest of your day. It's been fabulous getting to see all these sessions throughout the week. So one more day to go. We'll see you guys here tomorrow for PL SQL with Chris Saxon and Jeff Smith. So take care. See you then.